What is stress concentration? The most important part, what we are actually dealing with every design and every geometry. Stress concentration is something which is defined uh, as an area or a zone where the amount of stress is more than normal. What does it mean is that there may be a zone where the stress is maximum and where the stress is minimum. So, as we have discussed in other topic also, in fatigue one, that maximum stress, minimum stress, that that makes a problem. Now, for example, if we consider the zone over here and here, this zone are having a maximum stress because it is resisting itself from distortion. But here we are getting minimum stress. Why? Because there are materials which can resist themselves. Okay, so that's why we have to find out how to calculate the stress concentration or stress, how much stress concentration is occurring due to some holes or some sections in a design. So that is completely a geometrical way to find out. Now this is done by a stress formula named as K, that is defined as stress concentration. K is equal to sigma max by sigma average. So what happens is that there are the ways how you can understand that a stress is flowing smoothly. The lines of stress are smoothly. The lines of stress are smoothly. The lines of stress are here also smoothly. Why? How? See, here you can see a small curve, and as you said, you can see here small curve. What to eliminate these things, what we did is in one section, that is over here, we have done a curve over there, that is a curve. Okay, after that what we did, we just did some rules. So this can be done when there is a small like this, where you can see it small like this, that is a step one or a sharp corner. You need to go for your what to say, uh, for fillet zone, and you have to do the fillet works. And if you do that fillet zone, it will be a way where space is be distributed equally. Next is your, this is a pattern where you can find out maximum places where you can find out. Now here comes how is the stress, what will be my stress, and how to find the stress. So what I can do is that, now let me give one reference. This fillet radius is r, and this height is h, the small one, and the bigger height is w, and the load applied is p. What happens is that to find out k, that is kt or k, the stress concentration, what we can do is that uh, we can find out the ratio by r by a, that is radius of your fillet by height of this section, and this ratio will be considered, will be getting over these things. This has been standard that this ratio will be in between, will be either 1.1 or 1.2 or 1.5 or 2 or 3 or 4 at because that would be the uh, this is a standard one that would actually help us to get which curve is required. We know what would be R by H, and we can also find W by H. W by H. W is the biggest height and the smallest height. On this ratio is also fixed, and this has been done by our ASM. Now we know which curve will be working. We know the ratio. It will be hitting to the curve at a certain point, and that point will be corresponding to your KT. That means a curve and the ratio hit in a point, and this gives you a value. That is your say your KT value. Now, let us consider this one, which is having a radius of r 10, and small is 20, small length is 20, bigger length is 40, and the thickness is 10, LFL is 115. What will you finding next? R by H 10 by 20, as I told you, 0.25, W by H 40 by 22. As I can see that from the curve we are considered two parametric curve, and the value of 0.5, and we'll be getting a value of 1 k of 1.4, because the point where it will be striking, that back point will show the my what is my KT value. Next is how to compute it. We know that sigma average equals to force by area. Now, what is the force? We don't know the force. So from there, we can find out what is the force it can take. What we can do, sigma average or sigma normal, you can say, is equals to this one. Now we know sigma allow is equals to sigma max max yield. That means how much it can take. So what I can do, k is equals to k is equals to sigma allow by sigma average. So what happens is that k value is 1.4 and average is 0.05 and allow is 115. So from there you can find out what will be the force you can apply on that body till its failure. So similar like that, if you put one hole, you make one hole, you can find out what it. Now here is only one curve. You don't have to get several curves. What you just need to find out the value of r by w. That is r is the radius of this hole, and w is the width of this section. From that, where it will be striking, and you have to find out. Similarly, this is our other sections also we have for others graph we can you that will be in your present in your book like VV Bandari, from where you can see that there are many sections, many ways you can find out the uh, uh, your stress content. The main way out is you have to see in the graph only r by h, w by h, that would be the given, nothing more than that. You don't have to go out of the graph, you don't have to struggle. That's not rocket science. You need to just observe the car, observe that graph. You can see that it's written what ratio to be taken and what ratio not to make. There to be indication like R by H, W by H. Okay. So any issue, just comment over down below the video and I'll help you out. Thank you.